Here we are, video number 4 in the series in the introductory material in chapter 4 for engineering economy. Today we're going to look at a couple of things as much as a brief time will allow. The first thing we'll talk about is cash flow diagrams that are presented in the book. And this is section 4.5 of your text. And the other thing we'll do is we'll talk about how cash flow diagrams are very important, but because we're focusing on using spreadsheets, we will create a thing called cash flow tables. These are not discussed in the textbook. So here in this video is where you'll get all the information you'll have on cash flow tables. The other topic that I hope we'll be able to get to briefly is notation. Again, just like every other subject area, there's ways that we have to communicate more efficiently and effectively, and notation is one of those. So you have to struggle through learning the notation. The notation that's introduced and used primarily in the textbook, which is standard engineering economic notation, very important to understand it. But it's used primarily for communication and for solution by hand. Along with the notation in the text, there are tables in the appendix in the back of the textbook that provide what's called discrete compound interest factors. And these are all very well and good, but we will not be using those. We will use the power of the spreadsheet. The power of the spreadsheet allows us to dispense with the tables, which is a good thing generally. Although we might use them to solve, you might find them handy to solve some of the homework problems. But the notation is a little bit different when you use spreadsheets versus the textbook. So I have posted on the classroom site, and I will discuss briefly today a sheet that provides for a translation from the book to spreadsheet notation. Spreadsheet notation is standard across all of the spreadsheets that I'm familiar with. So whether you use OpenOffice, LibreOffice, one of those versions on the Mac or PC or Excel, or Linux, whether you use Excel, whether you use Google Sheets, Numbers, you name it, I believe the notation carries across from one to the other. So we'll talk about that briefly. First, what I'd like to do is talk about cash flow diagrams, show you a couple of them. They're pretty straightforward. There are some key things to make note of. And I encourage you, as you solve problems, to sit with a pencil and paper and draw a cash flow diagram. I won't draw them. It's hard for me with my equipment here at home to draw a cash flow diagram for you as we solve problems. I'll be using cash flow tables. We'll talk about those also, but I really like cash flow diagrams and encourage you to use those. Cash flow diagrams are a very, very, very simplified tool that's, I say, simplified analogous to a free body diagram in statics. When you have a statics problem, which most all of you can identify with there, if you've had statics, you show the forces on at a particular location, and that's how you can get a better idea about how to solve the problem. In engineering economy, we have the same general thing. We call them cash flow diagrams, and these cash flow diagrams are a graphical depiction of the cash that flows in a problem that is described in the problem statement. We are working in cash. We don't do credit in this class, except way late at the end. We'll talk a little bit about credit. But what we're mostly concerned with here, even though we might talk about borrowing money, it's the cash flows related to that. So our problems are all revolve around the flow of cash, essentially in your pocket or out of your pocket. And your may be you personally, may be a corporation, maybe your department in your company. It's cash flowing out, cash flowing in, and that's represented on a cash flow diagram. And cash will flow at specific periods in time. We start out by using years or months. We'll play around with that later. We'll talk about changing interest rates later. All that's later. But for now, we'll just talk about periods and when cash flows during those periods. So let me first bring up on the screen here the cash flow diagram that is figure 4.2 in your textbook. It's on page 113 in my 16th edition. And I just want to look at that briefly and go through it. It refers back to table 4.1 that we had on the last video. And in that regard, it's that alternative where we borrowed $17,000 and we had 3 different plans to pay it back over a 4-month period. But let me grab it and get it up here for you. If I can. That's not really what I want to share there, but let's look at that anyway. This cash flow diagram is not figure 4.2. I've got that someplace and I'll try to find it and throw it back up. This may be just as helpful. Notice that this cash flow diagram covers time 0 through 10. And we have cash flows at the end of year 2. The cash flows that we're concerned with here, all, unless otherwise noted, all happen at the end of the period. So the $1,000 you see there is at the end of year 2, and that is an arrow going down, which indicates a negative cash flow. So that would be $1,000 out of my pocket, out of my company's pocket. We spend $10,000. In years, at the end of years, which is what EOY stands for, end of year 4, 5, 6, 7, those 4 years, there is $1,000 positive cash flow each year. So the $1,000 above that line indicates that it's the same each and every year. It's not $1,000 total. It's $1,000 each year. At the end of years 8, 9, and 10, we have positive cash flow of $1,500 for those years. And again, that's a positive cash flow. It's money in my pocket or in my company's pocket, $1,500 each year for those years. And then also at the end of year 10, we have a negative $2,000 cash flow as well. So at the end of year 10, we have $1,500 coming in and $2,000 going out. And that is that's our cash flow diagram. Every problem that we have, we will be able to draw a cash flow diagram that represents the cash flowing and the time that the cash flows for the problem. Now let me take that same cash flow diagram that we just looked at and we will convert it to a cash flow table in a spreadsheet. And the concept of the cash flow table is the same as the diagram, but without the arrows. We could draw arrows if we wished. And it's transposed, so it's flipped on its side. The years go down instead of going across. And we will indicate the cash that's flowing for each year. Let me yank that up here and show you what that looks like, I hope. There we go. There's that cash flow table, if you will. And in that cash flow table, we're looking at the cash flows in each of those years. So here at the end of year 2, we have our negative $1,000 cash flow. At the end of years 4, 5, 6, and 7, a positive $1,000. At the end of year 8, 9, and 10, you'll recall we had $1,500 for each of those years. In year 10, we had $1,500 positive cash flow and a $2,000 negative cash flow. Those occur at the same time, and that gives us a net negative cash flow of $500. So that's a cash flow table. That's the way we will represent our cash flows in problems when we solve them. We'll have a cash flow table that indicates all of the cash flowing at any particular point in time. I hope that's pretty clear how we translate and transfer from a cash flow diagram to a cash flow table. Let me now pull up that figure 4.2 and just discuss that briefly, because there's some things that we need to look at. Excuse me. There we are. As we examine this cash flow diagram, this is recall this is Plan 3 from Table 4.1, where we borrowed $17,000 at the end of year 0, and time passed and time passed, and at the end of the 4th month, the entire lump sum was repaid, including the interest and the original amount borrowed of $17,690.27. A couple of things I'd like to point out. First of all, notice with the cash flow diagram that between 0 and 1, time is passing, and this is the first year, right? Just like a new baby is born. My grandson Jude was born last February 26th. That was time 0 for Jude. And as he gets older and older and older, and as he got older, since we're talking about months here, as he got older and February 28th and March 1st and March 15th passed by, and on March 26th, bingo, we're at the end of month 1. That would be time 1 for Jude. And that's the end of the first month in this problem that we examined. Notice also there's an indication of the interest rate, 1% per month, the rate at which we move money from one period to the next. And P is a present amount. F is a future amount. So P is where we started and F is where we ended up. There's another thing you need to understand about these cash flow diagrams, and that is a perspective. There are always 2 different perspectives that you can be represented in a cash flow diagram. This is from the perspective of the lender, not the borrower. And how do I know that? It's because at time 0, the $17,000 is negative. It's out of my pocket to somewhere else. That would be the perspective of a lender who lends money at time 0. So they take $17,000 that they have and they loan it to someone else. So they no longer have it in their pockets. The borrower has it in his or her pocket. So from the borrower's perspective at time 0, this arrow would have been up. It would be a positive cash flow. At the end of month 4, for the lender, again, this is a lender's perspective, the lender receives a positive cash flow of $17,690.27. If this were the borrower's perspective, the borrower at the end of month 4 would pay out the total amount due on the loan, the $17,690.27. So it's important to know those elements of the cash flow diagram, and we've seen the other cash flow diagram there. So hopefully that's sufficient introduction. Again, every problem that you have, you should. I would encourage you. I'm not going to force you, but I encourage you to please draw a cash flow diagram, create a cash flow table. It will make things much easier to solve the problems. Now, what about this notation thing about moving money around? We will be moving money from one place to another. And I have another thing I want to show you here very quickly, which is this conversion table. And I would like for you to look at this. This has been posted, and you should be able to download this from the classroom site. Please keep this close, at least for a while. And this shows you conversion of these factors, which may mean nothing to you yet, and we'll get there. But this is the notation. On the left-hand column is the notation that you'll see primarily in the book. The right-hand column represents, and I've got it labeled Excel, but it's really any spreadsheet, represents a conversion from what you need with respect to the textbook function factor to the Excel function. And this would be the equivalent Excel function you want to use if you would use this textbook notation on the left. Notice in particular, and I'll talk more about this as time goes on, notice in particular these negative signs in front of some of the functions. I guess all of them here, and this is not all the functions we're going to use, but the negative sign here, and there's a reason for that that we will, I'll discuss when we get to that point. But you need to do that to get the sign right on your answers. So so keep that close to hand when you start to use the spreadsheets. Now, in order to introduce that, I want to show you one more cash flow diagram. And in this cash flow diagram, I'm going to start to show you the use of these factors. And you'll be able to read those in section 4.6 of the text. And it's important that you read through there and let me know if you have questions. The notation can be challenging at times. The timing of cash flows with respect to the notation can be challenging, and I'll have a video about that pretty soon. In this video, we'll just introduce that. So again, let me share my screen and let's look at a particular cash flow diagram. And there it is. In this cash flow diagram, we have positive cash flowing at the end of year 3, positive cash flow at the end of year 6, and a negative cash flow of 500 at the end of year 9. One of the things we'll be doing in this class is looking at a cash flow diagram like this and pulling all those numbers together as one number that represents those cash flows. As you know, as engineers, we typically want to divide a problem up into steps, parts, if you will, and solve those. And we will do that here. And what I will do very briefly here is I'll show you how we would pull these 3 cash flows together in one that represents all 3 of them. And it will be, we're going to make one economically equivalent cash flow at here at time 0. So step one, I will take $750 and I will move it from year 3 to year 0. That is, I'm going to take an amount of money that would occur in the future, 3 years in the future, and find out what it would be at time 0 given a particular interest rate. So I'll have the interest rate, and it's like, here's a question. If we were to deposit, how much would we deposit today so that we would have $750 in 3 years from today? That's kind of the question we would be asking. But remember in the last video, I said, try not to think of it as money growing in an account. Think of the interest as just part of a factor that's used to move money from one place, end of year 3, to another place, end of year 0, which is time 0 or today. So let's look at the next. I realize this is a little small on your screen perhaps. Here's what we use. Notice that the $750 at the end of year 3 is gone. We have moved it to time 0. And here is what we do to find the value. Here's the factor P given F, comma, 5%, comma 3. What does this mean? Let's start from the right-hand side and go across. 3 is 3 years. That is, we moved $750 3 years. 1, 2, 3. 5%, that's pretty easy. That's the interest rate. That's the interest rate we use on this problem. So we are moving the $750 5% per year. So this is a per period interest rate that we place in this argument, if you will. And the very first term here, P/F, is the following in words: present given a future. So this is given a future amount, which we were given $750. We want to find P, the present amount. So we would read this term, $750 times P given F, 5% for 3 years. This converts a single future value to a present amount today. That would be step one. So we would take the $750 and we convert it to an economically equivalent amount at time 0. Then we'll take the $1,500 and move it to time 0. And before we get there, we can say, sure, we know how we would do that, right? We know what that would look like. We would add to this $1,500 times the factor P given F. We want to find a present amount given a future amount. P given F, 5%, 6 years, right? 6 years. So that's what we have now. The 750 times P given F, 5%, 3, plus 1,500 P given F, 5%, 6. And now we have this negative $500 out here at the end of year 9. And I'm pretty sure you know what to do. We would then subtract, because it's negative, $500 times P given F, 5% for 9 years, minus 500 P given F, 5%, 9 years. And we would put all those together, and we would find out what the answer is, what the total is for that cash flow diagram, those numbers. And we would have then essentially converted or changed the entire cash flow diagram from 3 separate cash flows to one cash flow at the end of year 0, which is the current or value today. Finally, as I say that, let me close out by going back to that conversion table, and we'll go back to the table and look at those factors. And there they are. And let's talk about what these are. We just did P given F, some interest rate for in years, in periods, in years. We also have F given P, a future value given a present value. So if we had $1,000 today, we would want to find what that value is perhaps 10 years in the future, given a particular interest rate, right? So that would be F given P. Let's stick with 5%, 10 years, 5% per year, right? 10 years. We'll stop there. We will introduce A little bit later. We know now that P is a present amount, F is a future amount. A is called an equivalent uniform annual amount, and we will talk about that in our next video. Make sure that you keep these handy, and at the next video, we'll be using the PV and the FV functions, and we'll use those to solve some problems. And then we'll jump to the A, F given A given F, P given A given P, all of those different factors, and we'll solve more and more complicated problems. That's all I have for this video. I hope it's been a little bit of help. The notation can be tricky. End of year cash flows, very important that you always remember that. The timing of the cash flows gets a little more tricky as we introduce the equivalent uniform annual cash flows, and when those happen in relation to the present amounts and the future amounts. But that will come clear as we work through some problems, working through sections 4.6, 4.7 in particular of the textbook. And you'll find these, you're going to need these for the homework, homeworks 2 and homeworks 3, which have been posted as of the time I record this video. So I hope you're, I guess you don't have to be plugging away yet because class doesn't officially start until, I think, tomorrow, Sunday, strange day for class to start. But that's it. When you do start, make sure you feel free to drop me or Missy some emails if you have questions. We'll be glad to answer those. I may have to head out of the house now and go see if I can find some good after Christmas shopping deals. So I'll check in next time on video number 5. Stay tuned.